Good morning, everyone, and a Happy New Year to you all. My name is Keira Proctor, and I'm the Managing Director of the A Proctor Group Limited, and welcome to the first of our 2021 webinars. We've been running these regularly since April last year, and the full series is available on our website at www.proctorgroup.com or right here on our YouTube channel. We were planning on beginning our 2021 series later this month, but as we're back in lockdown and in response to some of the feedback from you all, we've decided to rerun some of our previous webinars alongside the new content. We'll have a new live Q&A session afterwards though, so any questions you may have, please type them into the YouTube chat here, DM us on Twitter at proctorgroup, or email us at webinar@proctorgroup.com. We're beginning today with our Passivehouse and Low Energy Housing webinar, which we originally broadcast back in June last year. I hope you enjoy it. Today we're going to take a look at how we design housing with low energy use in mind, and how the principles and guidelines of the Passivehouse standards can inform that. While the Passivehouse standards themselves provide an excellent framework for low energy design, the strategies they embody can be applied to benefit all housing, regardless of the regulations and assessments applied. So we'll begin today by taking a look at what those principles are and what requirements and standards apply to meet Passivehouse certification. We'll then move on to consider how these concepts can be applied in a more general context, bringing the benefits of low energy design to all types of projects. The Passivehouse framework originated in the late 1980s, with ideas developed by Bo Adamsson of Lund University, Sweden, and Dr. Wolfgang Feist of the German Institute for Housing and the Environment. These research projects led to the construction of several experimental homes in the German city of Darmstadt. Building on these early 90s experiments, Dr. Feist founded the Passivehouse Institute in 1996, with the aim of developing and refining this concept and ultimately promoting its use around the world. From the first projects outside of Germany in the early 2000s, Passivehouse certified buildings can now be found all over the world. The actual standard itself, however, only codifies a set of principles that have been applied to buildings for a considerably longer time, even back as far as the Middle Ages, albeit in a far less refined form. As building regulations have developed and energy performance has become a more important consideration, elements from the passive principles have become more and more integrated into modern homes and are increasing beyond high-end self-build to be part of mainstream housing practice. There are 5 basic passive principles: thermal insulation, thermal bridge free design, air tightness, ventilation with heat recovery, and Passivehouse windows, or more generic, high-performance glazing. The purpose of designing according to these principles is to minimise the energy inputs required to maintain a comfortable indoor temperature. Ideally, the space heating and cooling energy requirements can be reduced to the point that passive sources such as solar gain and heat from the building occupants are sufficient for the most of the time. The Passivehouse Institute provides software known as the Passivehouse Planning Package, or PHPP, to calculate these energy loads, and provides prescriptive guidance and details along with product certification. While this approach certainly simplifies the process and ensures rigorous adherence to good or best practice, it does not always allow designers the necessary flexibility to balance the full range project requirements. In such case, the Passivehouse guidance and principles can be viewed as best practice recommendations for designing buildings assessed by other means such as national building regulations. That said, the verification and certification services provided by the Passivehouse Institute can serve to greatly simplify planning and approvals for such buildings and reinforce confidence and trust with subsequent buyers and sellers. So let's now consider how the 5 basic principles can be applied and what they mean. Thermal insulation is what limits the loss of heat from the building envelope and is the cornerstone of the fabric-first approach to building design. This approach seeks to maximise the performance of the basic components of the building, rather than relying on mechanical or electrical systems. The fundamental physical property of insulation material is their thermal conductivity, also known as the K value or lambda value. This property measures how well heat can flow through the material by conduction. In this mode of heat transfer, the heat energy is transferred between the individual molecules of a material by direct contact. Because of this reliance on physical contact, there's a correlation between the material's density and its thermal conductivity. So less dense materials such as foams and fleeces are less able to conduct heat than denser materials like bricks or concrete. Bricks, for example, have a thermal conductivity of 0.77 watts per metre Kelvin, while our space-therm aerogel insulation is far lower at 0.015 watts per metre Kelvin. Thermal conductivity, however, only looks at the basic material. It doesn't account for the thickness. To factor in the material thickness, we take thickness in metres and divide it by the thermal conductivity to give us the thermal resistance, or R value, in metres squared Kelvin per watt. The next step is to convert that into a value for an entire wall, for which we use the thermal transmittance, or U value, which is the inverse of the sum of the other R values for the different layers in the construction. U values are quoted in watts per metre squared Kelvin. Where R values vary proportionally to thickness of materials, U values do not, so as we move to lower U values, we need to add exponentially more insulation to improve them further. As an example, the limiting fabric parameter, more commonly referred to as the backstop, or worst permissible U value for a wall given in approved document L for England and Wales, is 0.3, and the recommended worst case for Passivehouse is 0.015. The best practice Passivehouse value is considerably lower at 0.06. In practice, compliance with either standard is more complex than achieving a simple maximum U value, but roughly speaking, the worst case U value for a Passivehouse would be considered pretty good under national building regulations. The next principle is thermal bridge-free design. A thermal bridge occurs either where a material of higher thermal conductivity intersects a less conductive material, or where building elements join, such as at floor zones or corners. Thermal bridges have two principal negative effects. Firstly, they increase the overall heat loss by providing an easier pathway for heat to escape, and secondly, they create cold spots internally. Condensation and mould growth can occur in these areas, which has a detrimental effect on the indoor environment. The first of these, typically where structural elements like studs in a timber frame wall intersect the insulation, is accounted for via an adjustment in the U value calculation. This takes the thermal conductivity and proportional area of the bridges and adjusts the U value accordingly. If we consider a 140 mm thick panel of rigid foam insulation, if we use this in a typical timber frame wall, the U value then adjusted to account for cold bridging at the timber stud will work out to around 0.22. On the other hand, if we eliminated this cold bridging but used the same thickness of insulation in, for example, a structural insulated panel system, the U value drops to 0.15, purely due to the lack of repeating thermal bridges at the studs. Thermal bridging at corners and junctions is accounted for using an additional value for linear thermal bridging, known as a psi value. But in most cases, these are addressed using standardised pre-assessed details to limit heat loss. The easiest way to visualise the way thermal bridge-free design works in practice is to simply imagine drawing a pencil line around a cross-section of the entire heated envelope of the building. If that can be done without touching anything other than insulation, the design is free from thermal bridges. Because of the adverse effect that thermal bridging has on both the U value of individual elements and the overall energy performance, whether assessed via PHPP or SAP, reducing cold bridging in low-energy building is a matter not just of principle, but also of practicality. Getting U values anywhere close to Passivehouse's best practice performance levels without restricting thermal bridging is virtually impossible. But even in cases where designers are aiming for lower standards, the benefits regarding limiting localised condensation are clear. Whatever the assessment criteria, high-performance insulation systems like the space-therm aerogel have a very important role to play in minimising thermal bridging by allowing the thermal resistance to be maximised at any given point. In locations such as window reveals and door openings, it can be difficult to maintain a similar level of insulation to that found over the main sections of a wall, leading to these areas being relatively cold. In extreme cases, this can cause the temperature to drop to the point where condensation may occur in these areas, and as fabric insulation levels increase, so does the importance of continuity and uniformity. Systems such as SpaceTherm, which provide high thermal resistances in minimal thickness, allow for a more uniform envelope of thermal insulation performance, with the localised drop in R values around complex features minimised. The fire-rated SpaceTherm Slentex A2 system also allows this continuity to be maintained where reduced combustibility is required, offering significantly higher performance per unit of thickness than conventional fire-rated insulation, such as mineral fibre. Fibrous insulation quilts typically have a thermal conductivity in the range of 0.035 to 0.44, which the SpaceTherm is 0.015 to 0.19, meaning like-for-like performance can be achieved in less than half the thickness. While big thicknesses of insulation are expected and accounted for in passive and low-energy projects, it's not always possible to maintain such thickness over every part of the structure. SpaceTherm can allow this uniformity to be achieved, and being of comparable permeability to fibre quilt to be achieved without compromising moisture movement. SpaceTherm can be supplied in a variety of laminated board systems to suit most applications, as well as in self-adhering cold bridge strips for direct bonding to structural elements such as steelwork. This need to create uniformity of insulating value and prevent cold spots is also an important aspect to consider when specifying the windows in low-energy and passive projects. Passive and low-energy homes must pay particular attention to the specification of windows used, as poorly insulating windows can not only affect the overall heat loss, but, as with cold bridges, can also create cold spots and cold radiation. This phenomenon occurs where the influence of a cold surface can be felt nearby, often leading to a perception that a space is colder than it really is. Even by using multiple layers and glazing, inert gas fills and thermally reflective coatings, windows still typically fall a long way short of the performance of the rest of the building envelope, with the Passivehouse specifications calling for windows with a U value of 0.8 or less, significantly above the opaque elements. Windows are also important to provide heat into the building via solar gains, and for this reason, passive houses in heating climates like the UK tend to position majority of glazing facing south in order to maximise this effect. This requirement to maximise collection of solar heat has to be carefully managed though, as highly insulated and airtight homes can be susceptible to overheating if this is not carefully assessed and managed. It's a common misconception that passive houses do not have opening windows, but in fact the specifications call for at least one opening window per room in the living spaces. Opening windows is among the most cost-effective and simple means of counteracting overheating, and is useful to prevent poor indoor air quality in exceptional circumstances such as large gatherings. That leads on to the next concept we need to consider, the airtightness of the structure. It's often said that airtight buildings can be like living in a plastic bag. However, this is a fundamental misunderstanding of what we mean by airtight buildings. Reducing air leakage simply means eliminating sources of air infiltration and exfiltration over which we have no control, drafts in other words. A good supply of fresh air is a critical component of healthy indoor living environments, and the Passivehouse specification is designed to ensure this is facilitated by controlled and carefully managed ventilation systems, with considered impacts on energy performance. Uncontrolled air movement, on the other hand, should be reduced as much as possible. As we've covered already, the thickness of insulation layers increases exponentially with reductions in U value, and after a certain point this becomes both uneconomical and impractical, even in explicitly low-energy buildings. It's therefore very important that every other factor affecting energy performance is controlled and limited to minimise energy usage. In dwellings, there are two main drivers of air leakage: the internal stack pressure caused by the relative buoyancy or warm air and resultant convection, and external forces from the wind. Because warm air is less dense, it will rise upwards in a building and can leak out of any air pathways found at higher levels. Correspondingly, as this air rises, colder air must be drawn into the building lower down. As the warmer air will contain significantly more moisture, this outward air leakage can lead to condensation issues as the leaking air cools and deposits liquid water. The cooler air entering the structure lower down will lower the internal temperature in the building, necessitating energy input to maintain the temperature of the habitable space. Externally, the wind forces acting on the building will have similar effects, but inside of the pressure gradient working from bottom to top, it will be aligned to the wind direction. Cold air will be pushed in on the windward side where there's a positive pressure, and warm, moist air sucked out on the leeward side where the pressure is negative. Limiting this air movement is a critical part of the low-energy design, as even highly insulated building will have poor energy performance if the movement of air is not controlled. Both the building regulations and Passivehouse standards therefore include pressure testing and minimum performance levels, but there are some important differences. The UK building regulations use a pressure test known as AP50, which is the volume of air in cubic metres that flows through the building fabric area in square metres in 1 hour when a reference pressure of 50 pascals is applied. This pressure can be applied in either direction, by pressurising or depressurising the building. The backstop value for this is 10 metres cubed per metre squared per hour in England, Wales and Northern Ireland. In Scotland and the Republic of Ireland, the preferred or reasonable limit is set at 7, and while it's theoretically possible to comply with a higher value, the necessary trade-offs will generally be unacceptable. Passivehouse expresses the air leakage differently, using a standard called N50, which is the air changes per hour through the building's internal heated volume, ACH, at the same 50 pascal reference pressure. In the Passivehouse test, however, the pressure must be applied in both directions, pressurising and depressurising the building, and the two results averaged. The test equipment and physical procedure is largely the same for both AP50 and N50 tests. This means it's perfectly possible to run both simultaneously, but the way the final results are calculated is sufficiently different that conversion between the two values is not possible without access to the source data. The BRE's Passivehouse Airtightness Primer document, highly recommended as follow-up reading, gives a useful analogy to illustrate the difference in standards. A building with an air leakage rate roughly meeting the UK regulations limiting value of 10 metres cubed per square metre per hour AP50 will have gaps and cracks equivalent in area to 120 pence per square metre of floor area. In contrast, a Passivehouse meeting the required 0.6 ACH N50 standard will have gaps equivalent in area to a 5 pence every 5 square metres of floor area. There are numerous ways of making buildings airtight, and finding the most appropriate method to apply to a given project is usually a matter of balancing a variety of competing requirements. Some strategies are easier than others, however. Some building materials, such as cast concrete, cross-laminated timber and structural insulated panels, have an inherent advantage when it comes to air leakage, as the basic materials involved have low air permeability. Others, like blockwork, are more permeable, so require additional measures to control air leakage. In all cases, though, junctions, services and the nature of the on-site assembly process still poses challenges to achieving a low air leakage rate, even when using the most impermeable base materials. The conventional solution to this is to seal the inside of the building using a vapour and air barrier membrane. The advantage of this approach is that the membrane fulfills a dual purpose, limiting both air leakage and vapour ingress into the structure. It's also something most contractors are familiar with. The downside to this approach is that the membrane integrity can be compromised by a variety of components and processes. Being internal, building services such as power, plumbing and network cabling must run through an internal air and vapour control layer. While this need not necessarily pose a problem, the nature of sites and trades, particularly in the UK, is such that VCL integrity cannot necessarily be depended on. Unless contractors of all disciplines are aware of the importance of this layer, suitably trained and equipped to avoid damaging it, and afforded sufficient time and space to undertake works in a manner that avoids puncturing this membrane, the scope for problems is limitless. Features like service voids, flexible pipe and cable gaskets, and sealed light fittings can all go some way to mitigating these risks, but these all increase costs and time demands, and aren't necessarily familiar to all contractors. For example, in Scandinavian countries, where low air leakage rates have long been standard practice, every plumber and electrician will be used to working carefully around air barriers. However, in the UK it's not uncommon for holes to be cut and drilled and work undertaken with no thought given to any knock-on effect on air movement. It can also take far longer on site to ensure every joint and penetration is adequately taped and sealed, often requiring different types of tapes for different circumstances. Acquiring all these tapes and sealants can also pose challenges if needed at short notice. Although this is changing gradually, with more contractors gaining Passivehouse certification, it's perhaps prudent for specifiers of low-energy buildings in the UK to look at alternative methods to mitigate these risks at the design stage. Moving the air barrier layer to the outside of the building, well away from any services and following trades, allows this to happen. Our Raptite product is a self-adhered, vapour-permeable but airtight membrane suitable for use in both wall and roof applications. It's also certified by both the Passivehouse Institute and the BBA, so can be specified with confidence as an effective air barrier layer. On the outside of a building, there are far fewer penetrations to seal, and those that are present tend to be larger and simpler to seal. Because the membrane is adhered fully to the substrate, it's also better able to resist damage. The self-adhesive backing also makes sealing laps and joints simple and fast, and the membrane itself can be fitted off-site, allowing it to provide protection during transportation as well as being used in the construction. In an off-site installation, the joints between adjacent panels or modules can be simply jointed on-site using our split liner tape, which ensures fast and effective seals can be made in the air barrier. This also facilitates straightforward sealing of complex curves and forms, and means features such as floor zones and roof and wall junctions can be easily dealt with by simply wrapping the whole building in a single product. Once fitted, the building shell is then wind and watertight, so progress can be made on fitting out and air pressure testing can be undertaken earlier in the build scheme, giving more flexibility on timings and potentially easier fixes to any problems that do arise. The primary benefit of the Raptite system is not so much that it reduces the overall air leakage rate, more that it makes achieving design air leakage rates far easier and more reliable. This in turn allows the benefits of airtight construction to be fully accounted for and integrated into holistic design, without fear of expensive and awkward remediations if targets are not met. The vapour permeability of Raptite also allows flexibility in insulation placement. It's perfectly possible, for example, to wrap a building with insulation between stud-work and Raptite, then fit additional external insulation layers to limit cold bridging without causing any moisture problems. That's not to say that we do not need to consider moisture control in this type of construction. An internal vapour and air barrier will also serve to limit the ingress of moisture vapour into the construction. So if we move the air barrier externally, we need to ensure that moisture is adequately controlled to prevent any condensation problems from arising. This can be achieved by either using insulation with a lower permeability to moisture vapour, such as most types of rigid foams, or by using a warm frame construction with insulation placed externally to limit temperature drops and ensure the dew point does not occur internally. Another option is to use a variable resistance membrane, such as our ProCheck Adapt. This type of specialist membrane has been used in Passivehouse constructions across Europe for many years, and when combined with an external air barrier membrane provides a comprehensive moisture and air movement control solution. The ProCheck Adapt varies its resistance to moisture vapour according to the environmental conditions, becoming more resistant to vapour ingress in winter when condensation risks are highest, and then less permeable over the summer to facilitate drying out and allowing a more breathable construction. Used alongside Raptite, ProCheck Adapt provides an additional level of protection against both air leakage and moisture issues. Any moisture that does not make it into the construction as a result of damage during installation can easily dry out in either direction, which the movement of air is reliably restricted by the external air barrier. We also have the capability to run WIFI-based condensation risk calculations. This covers a wide range of factors to ensure buildings are able to manage the interactions between heat, air and moisture movement. We've covered this in more detail already in our Membranes Explained, an Introduction to Building Physics webinars, and you can go back and review those on our website or YouTube channel if you'd like a bit more detail on that, or you can book a virtual meeting with one of our team if you'd prefer. The last of the passive principles is the use of ventilation with heat recovery, in which heat from the extracted airflow is recovered through a heat exchanger and fed back into the building via the incoming supply air. This improves the efficiency of the building by reducing heat wasted by the extract airflow, and such systems are generally required as part of the Passivehouse certification. Without heat recovery ventilation systems, it can be difficult to meet the space heating energy requirements. This requirement in the Passivehouse specification often leads to an incorrect assumption that all airtight buildings require mechanical ventilation. If designers are not working to the Passivehouse certification specification, then various other options for both ventilation and heat recovery are available. In fact, it's perfectly possible to have good indoor air quality at low air leakage levels with a fully passive ventilation system, provided this is designed into the building early enough. What's important here is ensuring the building as built meets what is specified, and here's where systems like Raptite are particularly useful. If you design the building heating and ventilation systems to operate with an air leakage rate of 3 meters cubed per square metre per hour, but when tested the building only achieves 7, then problems can arise as highly optimised heating systems may not be able to compensate for this shortfall. Conversely, if you design to 7 meters cubed per square metre per hour and actually achieve 3, then ventilation may not be able to supply sufficient fresh air to provide acceptable air quality. What's important is ensuring the building is constructed within its design specification, thus allowing all the building systems, active or passive, to perform as intended. A further possibility for the recovery of heat to lower the energy use in a home is to use heat pumps in the heating system. There are 2 primary types of heat pump, air source and ground source. Air sourced heat pumps, or ASHPs, use heat exchanging fluids and compressors to extract heat from the ambient external air supply and supply it into the interior of the home via a more or less conventional central heating or underfloor system. Ground source heat pumps recover heat from collector loops buried underground. Fluid is circulated through these loops and picks up heat from the ground, which is then fed through a compressor and heat exchanger used to heat the home. Both of these systems commonly use a large water tank to act as a heat store, using the thermal mass of the water to retain heat energy until it is required by the heating and hot water systems within the house. Ensuring this heat store is well insulated is a critical part of ensuring these systems operate efficiently, and we have supplied the space air insulation in blanket form for use in insulating a huge variety of tanks and vessels. Both ground and air-sourced heat pumps are designed to operate at lower temperatures than fossil fuel or electric heating systems, and this lower operating temperature works particularly well with underfloor heating systems. These lower temperatures, as well as the lower running costs, mean that these systems are typically designed to run continuously or almost continuously, and have less scope than traditional heating systems to boost their output and to meet additional demand. The better the energy performance of the dwelling they are fitted within, the more effective they will be. This makes these kind of systems a good fit for low-energy homes. The relative lack of spare heating output also reinforces the importance of predictable and reliable energy performance at the specification stage, as the only practical solution to an under-spec'd underfloor heating system is often the use of auxiliary electrical or solid fuel heating, which may not be a good fit with an energy-focused project. Although it's not Passivehouse certified, my own house used many of these principles to deliver an award-winning low-energy design by Scottish practice Alan Corfield Architects. Completed 2 years ago, it's a structural insulated panel home and adopts the passive principles of thermal bridge-free design and highly airtight construction, and also used a mechanical ventilation system with heat recovery to minimise energy requirements. If you've been following our webinar series, we discussed structural insulated panels last time, and this particular system is the Kingspan Tech panel system, supplied and erected by SIP Scotland. These type of panels use a rigid urethane core with OSB facings, which limits cold bridging by having no structural penetrations through the insulation layers. OSB also delivers good air leakage performance, and this is boosted here by using both Raptite externally and our Reflectitherm Premier reflective vapour control layer on the inside. This reflective system not only lowers the U value of the wall with its 0.78 thermal resistance, but the adjacent service void helps minimise penetration through the VCL. This reduces the potential for moisture vapour ingress and further limits air movement. The Reflectitherm Premier, like the ProCheck Adapt, features an integrated lap joint tape, helping facilitate a good quality installation. The use of systems and materials which simplify installation, along with experience and expertise of specialist contractors familiar with the use of SIP systems and delivery of low energy focused projects, was key to delivering good results. So hopefully we've covered a lot of the basics today and given you a good overview of where to start with passive and low energy designs. There really is a wealth of amazing resources out there, from BRE documentation to the Passivehouse Institute guidance, and we've barely scratched the surface of the factors that go into creating and delivering a successful low-energy home. We do have a team of technical experts across the country, so anyone involved in these kind of projects, simply get in touch and we can assist right throughout the process. So we'll now move on to the Q&A session. Good morning, everyone. First of all, I'd like to wish you all a very happy new year. I hope you had and made the most of an enjoyable time with your close family on Christmas Day and made the most of it. We're early. We'd actually planned on our first webinar being on the 29th of January. So we do have one then, I'll come on to that. But based on the new lockdown measures, Good morning, everyone. First of all, I'd like to wish you all a very happy new year. I hope you had made the most of an enjoyable time with your close family on Christmas Day and made the most of it. I think we need Natasha to mute. Sorry, Natasha. Poor Natasha, and she's a new face on the panel this week as well. Don't worry, Natasha. If you close the first of all, I'd like YouTube channel, Natasha, on yours. If you just shut the YouTube channel. The joys of, at least you know we're live, guys. At least you know we're live. So not to worry, as I say, we had intended to have our first webinar on the 29th of January, but based on everyone being on, in their homes again, lockdown, we thought why not do one today? So what we did was we took some of the answers from the surveys that we've been sending out, and this particular webinar has come up as one that people would like to see a replay of. It was also a very popular one, so that's why we chose the Passivehouse and low energy one. So we are back on the 29th of January if you want to diary it just now. 10 a.m. as usual, and the topic will be the physics and applications of construction membranes. And that is new content, touches on some of the things we've covered last year, but the team are working hard, have been and are at the moment. So I see some good questions coming up in the YouTube feed there, particularly ones around the difference between air permeable, vapor permeable. We should be covering some of that stuff in that webinar. But again, we will answer some of these questions today. In our last webinar, I had asked for feedback, which we do get after every webinar, but I think there was a little bit of a prize in a hamper that we offered. So we picked out at random, and he has been advised and received and hopefully enjoyed his hamper. So if you're here today, Dougie from McKean Architects, congratulations, and we hope you enjoyed it. So we will stay here as long as it takes to answer all the questions that have been asked. So you can put them in the YouTube feed now or email us webinar@proctorgroup.com or DM us on Twitter or social media @proctorgroup. So we will be here as long as it takes to answer them all. If you'd like a product sample pack, more information, you can book a Zoom call with one of our technical team to discuss things in more details. You can do all of that on our website at proctorgroup.com/webinar, which has all the links to the content in this, sample requests, etc. And you can also sign up for the next webinar or the future one. So we have an excellent program of webinars coming this year, a mix of replays every 2 weeks and then brand new content at the end of every month. So we hope you can join us. It really helps us if you give us a thumbs up on our YouTube channel, or you can also subscribe to that, and then that will allow you to see new content as and when we put it on our YouTube channel. So I will just introduce the panel very quickly. You already briefly met Natasha. Morning, Natasha.
Morning, everybody.
So Natasha is our technical sales manager who covers the Midlands area. So obviously she's working from her home. You may have met Adam Salt before, who's now based in Telford. He's our technical sales manager for the Southwest. Pamela Howitt is our senior technical sales representative based up in Blairgowrie. And again, I see on the chat that someone has joined us from Snowy Blairgowrie, not an employee, but so welcome. We're all enjoying the snow here. And John Johnson is currently, I think, on mute. But he is our national sales manager, and I'm hoping that he manages to get his audio sorted quite soon if he can. However, we'll come back to John. So we will just start with some of the questions that we've received. So we've had quite a number from email already. I can see again more coming through on the chat feed, so please keep sending them and bear with me because they're coming through quite a few different platforms, so I will try not to miss any. So Adam, if we can start with you, if that's okay. Sarah has asked, as a developer who's looking more at achieving a green or lower energy construction, would you have any advice?
Yeah, so it's good also to have sort of contractors and developers watching, as well as sort of the architects that tend to come to these webinars. But yeah, definitely do your research. So if you're doing an existing property, understand the substrate that's already there. And then if you're building a new property, also understand the plot that you're going to be looking at and pick wisely, because if you're south-facing, your building's going to be south-facing, then you're going to get the benefits of solar gain, but you could cause overheating. So you need to think about the orientation there with your plot that you're going to build a new build on. For any build, you want to do some research into the products you're using. So sometimes you can have the greatest of product on paper, all designed, but when it comes to actually installing that on site, it can be very tricky and then lead to poor results. So at Proctor's, we do a lot of work with contractors and site visits. So we're starting to understand the build as much as possible. So when we do bring out those new products, we can understand not only the benefits in design, but also the installation stage. So Raptite, for example, is self-adhesive and goes external where there's less penetrations. So that helps, again, to achieve those low air tightness results a lot quicker than those traditional methods, a lot simpler as well. And then I suppose with these kind of projects, air tightness being key, just take a lot of care with installing those products. Take your time, because any sort of little gap, any hole, whether you're using a traditional internal method or an external method, is a potential for an air leak. Make sure you work with the suppliers and understand how those products can be installed to the best. Yeah, that'll help massively. And also thermal bridges within your construction, another good thing. Areas that might seem quite small in the build, but by addressing those, they can make a massive difference to your performance. So look at the thermal bridges as well.
Well, just coming on to that, and Pam, we'll just jump straight into the technical one on the back of what Adam was saying there about thermal bridges. And Tom Fisher has asked on the YouTube feed, how can he reduce thermal bridging in his build?
Yeah, I mean, it's a really important way of improving your efficiency, and not least in preventing cold spots where condensation could form, surface condensation, etc. could form. So there's many ways of doing it. So things like using a SIPS panel system, like yourself, Keira, have done in your building, because that's got less bridging in it. They fit together. They're designed to have less bridging. You can use a continuous layer of insulation, either internally or externally, to span across those cold bridging elements. You can design your joints and junctions to be less onerous on timber or steel to minimise those, to reduce the factors through there. And things like our cold bridge strip, our space therm cold bridge strip is predominantly designed for this. So that's an encapsulated blanket with a self-adhesive backing, which facilitates a temporary fix on a steel stud or even timber or rolled steel. And they're ideal for use on posts and beams, etc., lintels. We also have our space therm Raptherm, which is a combination of the Raptite air tightness layer along with the space therm, and that can either be used as a full blanket on your wall before you put up timber studs, especially beneficial in existing buildings or facade retention buildings. But because it's self-adhesive, it's brilliant for use on awkward steel lintels and beams in larger areas, to be wrapped around to reduce thermal bridging. In terms of continuous products, I've touched on the Raptherm, but you've also got things like the space therm wall boards and the thermal laminates there to line your walls. And probably one of the areas that gets forgotten about, I think Adam might have touched on it, is your window and door reveals. There's a lot of heat can be lost through there. So by not considering that, you can lose a lot of energy there. So make sure they're well insulated and well sealed as well. And we do our laminates down in smaller boards for window reveal boards for just that type of application.
Good. That was a good question. I mean, I think it's something that is quite often overlooked, as Adam said. And certainly for us as a business, we're getting more and more questions about cold bridging, which is great because it does mean that people in the sector are becoming more educated
Absolutely.
about the importance of it, which is fantastic. And sorry, Pam, just while I've got you, if I can just come to you quickly. Susie said, obviously, she's not a professional, but she's quite puzzled by the distinction between air permeable and vapor permeable. Now,
Yeah.
Susie, we have done a very in-depth webinar on the difference between vapor and air permeable membranes, which is on our site. But Pam, do you want to just answer for the benefit of others quickly, a quick summary about the differences?
Yeah, you're absolutely right, Keira. We've got some brilliant graphics and webinars out there explaining that. But basically, air permeable allows air to pass through it. So if you used it as a mask, using the poignant thing, if you used an air permeable membrane as a mask, you would be able to breathe through it. So it allows air to pass through, and it allows vapor to pass through in that air as well as by diffusion. When you're looking at an airtight product, it will allow vapor to diffuse through it, so that the construction allows that vapor to pass through in the gaseous state, as well as providing the airtightness line. So if you used an airtight membrane as a mask, you would be struggling to breathe through it. So that's probably a kind of sort of a poignant way of
explaining
the difference.
And when you say, just to clarify, when you say airtight, that often refers to a vapor permeable membrane.
Absolutely,
so airtight
absolutely.
vapor permeable membrane. Yeah.
So that can allow that through, but you wouldn't be able to breathe through it, so you don't have that additional mechanism. And depending on the construction, it's probably most critical in things like cold roof applications, where our roof shield would be used, where you want that additional mechanism of vapor to pass out, and not maybe for the low energy type scenarios that we're talking about here.
Okay, fantastic. I'm just going to keep going down the ones in the feed, and then we'll come on to some more via email. So Natasha, if I can come to you for the next one, please, that'd be great. James has said, I noticed you have Passivehouse certification for Raptite and ProCheck Adapt. Why is this different to BBAs, for example, and what are the benefits?
Oh, absolutely. So we do have separate certification for Raptites. We have BBAs, and then for Project Adapt, we also have the LABC certification. The benefits of having also Passivehouse certification is to allow designers to specify and include them in their detailing without any worry that it's sort of compliant with the Passivehouse regulation. So it's just sort of for ease of product specification, really. So some of you may have noticed on our website that our Raptite certification for Passivehouse is slightly lapsed, but we have been assured by the Passivehouse Institute that our certification is on its way in the post. So please feel free to specify in that sort of arena.
Okay, great. And John, we've got your mic issue sorted.
Yes, at last. I should be on radio rather than television, because everybody probably saw this massive panic on my face when I couldn't hear anyone.
You did start looking quite frustrated. I thought, oh well, good. Glad to have you. Good morning. Good morning.
Thanks.
So again, just a quick introduction. John is our national sales manager, so he looks after the UK sales team and has been with Proctor Group for many years. So a lot of experience. So John, we'll just use your experience now for one of the questions. Craig had asked slightly earlier on, why is there more emphasis on airtightness, MVHR and other sources of energy efficiency? Surely I can just increase the amount of insulation to make my building more efficient.
Yeah, it's a good question. It's one we do get asked a lot, and although it is important to consider the fabric first approach for a building, i.e. ensuring that you've got decent levels or good levels of insulation. It's about getting this balance right between the air tightness and the amount of insulation. Well insulated it is good, but unfortunately it's a case of diminishing returns. It gets to the point that you do to have a drop in the U value by any meaningful amount, you have to increase the thickness. So to explain it really, if you take space theorem on an uninsulated wall, solid wall, which would normally have a U value somewhere around 2.1, to take that down to around 8.87, you're looking at a U value of a drop of about 1.23. So you would get that with roughly about 10 millimeter of aerogel, if you like, or space theorem. which is quite a drop. But if you've got an existing building sitting, or a U value sitting at 0.15, for example, and you want to drop that to 0.1, you're looking at a very, very high level of insulation to try and get that down to the level that you need, and probably somewhere around about 95 to 150 mil. So once you start looking at the effects of timber bridging, less efficient insulation, depending on what type you've specified, the differences are far more pronounced. One of the best ways to ensure energy efficiency is controlling the fabric. That's what the fabric does, controlling air leakage and heat losses. Low levels of air tightness means less cold air coming into the building and less loss of heated air. So heat recovery systems, air or water, they help reduce the heat that you've already have and harness to preheat whatever air or water you have. So you need less power to bring that up to the temperature that you ideally need. So therefore, it's cost less to the homeowner to actually to bring that the heat and the water up to temperature.
Okay, good. Thank you very much, John. I'm glad we've got your mic working. And if I can come on to you one, just for one we've had via email here as well from Victor. I like to be able to have my windows and doors open in the good weather, but I also want to build a low energy house. Surely I can't have both. We get this question quite a lot. It's a great question.
Yeah. I think with under the current climate, if you look at with the COVID, there's many people having their windows open. And some buildings have actually got that as a not legislation, but a recommendation to open them at least twice a day. My wife has that in her place at the moment. So as Keira mentioned in the webinar, it is possible, and it's actually encouraged to open your windows when you build passive or low energy. Good air circulation is important for health, for the people in the building, but also important for the building fabric. And also in the webinar, Keira, you mentioned that to look at the balance of the building. If you want to have air from open windows, then design that at the beginning, make sure you've got that. And likewise, if you don't, and you'd rather have everything controlled by your MHVR systems, then again, put that in at the design stage. It is possible to provide ventilation either mechanically or passively, and there are many clever solutions being looked at and developed as the building practices move on in line with low energy buildings. We look at that in Europe. A lot of the European buildings have successfully included these types of technologies for years. And they've struggled to understand our reluctance to embrace this technology. But key really is it must be done at the design and considered properly, not just added as an afterthought. So make sure that if you are putting that in, that you look at that early in the design process of your building.
Okay, good. Thank you, John. Lots of great questions coming through. Adam, if I can come to you, please. Moises has asked, can a modular building be made into a passive house?
Yes, it can. It has been done. It will, again, depend on the manufacturer to whether they're going to do it. But it has been done. There's been a couple of projects out there. I know there's a lot more modular companies looking into it as well, just sort of the way things are going forward. But again, it comes down to the air tightness results and the amount of insulations, etc., to achieve those performances. But it can, in simple, it can be achieved from in modular as well. So.
Yeah, I mean, it's, you know, with modular, obviously they're done sometimes in terms of volumetric modular, but there are ways to obviously have good practice within factory systems to achieve lots of different outcomes, which we've experienced when working with our customers in the modular sector. So, and we have seen it done, Adam, haven't we? So
yeah,
absolutely. Good. Okay, Adam. Quite a generic question from Chris here. Are there any ways which I can improve my current property without doing a huge amount of work?
Okay, good question. Well, there'll be a number of ways, but I suppose every project's different. So they've got a number of things to consider, from the budgets, evaluating the existing substrates, and also seeing what sort of performance criteria you wish to achieve. Some sort of simpler things, I'd start looking around your house for where your drafts are coming in, potentially stopping those drafts and make sure you're sealing them correctly. Most common areas, I think, might have been mentioned before, but windows and doors. In the past, skirting boards, people used to put like newspaper under skirting boards. The issues with those, that you've got to lap different pieces of newspaper over, so those laps can be an issue. So people now look at using tapes under the skirting boards to stop that draft. Again, issues with tapes, if they're not impermeable, they can cause some issues with condensation. So things like our Raptite tape, which is breathable, can be a good solution for those areas. A lot of existing buildings as well tend to have uninsulated timber floors, so you can potentially fill the gaps in, but be careful, as this can have a knock-on effect to sort of other areas within that build, and important to get that right balance throughout your whatever work you do. A simpler method would be to sort of maybe put space firm multi along the floor, but again, it depends on your sort of project budgets and how much work you want to do for them. Adding insulation is always going to make improvements. A lot of people start off with their loft space and put insulation up there, so that can make an improvement. But then even adding onto your walls can be seen as quite a big job, but a thin board which has a high thermal performance, that such as a wall liner that can be adhered onto the wall, can make that a much more simpler and less of a big job process. So it really ranges. There's lots of things to consider. Happy to have conversations though, if anyone's got a project in mind, to get in touch.
Great, thanks Adam. Now, we are getting obviously quite a few questions coming through via email. We are not forgetting those, so I will get to those. I'm just trying to go through the ones on the YouTube feed. So there's sort of 4 or 5 coming through, really interesting ones on email, so I promise we will come back to them. So I'm just going to try and go through some of the ones we've had on the YouTube feed for now. Pam, if I can come to you, please. Andy has asked, can Raptite be punctured by standard timber frame brick ties?
Like anything, you want to limit your fixings through any air tightness layer. However, the Raptite is quite unique in the fact that it is fully self-adhered by its very nature. That adhesive and the nature of the composition of it will help to seal to a certain extent around it. Obviously, if you start sort of shredding into it and sort of repositioning brick ties, etc., that's going to be a problem. But we have carried out large-scale air tightness testing down at Adam's neck of the wood, Telford, with UL Wintec, and that was basically an 8 metre by 6 metre rig, SFS, floor junctions, windows, and penetrations through in the form of brackets. So there was like loads of brackets on it, loads of penetrations, and we got consistently very, very low air tightness values, or it was really airtight. And so there's like a chart of, as you go up to sort of 600 pascals, sort of from what's acceptable at low and what's acceptable at high, and we were consistently down very, very low, well within those parameters. So it's all about care, it's all about detailing, it's all about, if you're concerned, use things like liquid flashing to seal over. If you put a fixing in the wrong place, patch it, seal it, and keep those down. So normal brick ties are fine.
Okay, good. Thank you very much, Pam. And let me just come on to another one here. Sorry, a lot coming through. Mary Ann has asked, Pam, just on the same topic, similar product, if we stick with you for now. Can Raptite be used outside external insulation to give a water airtight layer? And does it need another layer of protection from weather, etc.?
Yes, so that ties in quite nicely with the brick ties. It's Raptite is a temporary or a secondary line of defence in your wall. So it's there to protect your structure during construction, and it's to protect that structure if there's a failure of your main waterproofing outer leaf. So that could be a rain screen system, could be a brick outer leaf, brick slips, that sort of thing. Depending on the construction that you're doing, Raptite can be placed on the outside of the insulation, but in a lot of situations, in a lot of the projects we do with Raptite, you would probably put it more on the sheathing, and because it's that vapor neutral, moisture neutral, it's not going to trap moisture in your building. So you could have insulation on the outside. It's protecting either your SFS and board system or your timber frame system behind it. So there's different placements for it. That's probably most applicable. And certainly if you're using a rain screen, you're going to be probably using a geo slab or a waterproof insulation externally. So there's no need to place that membrane. But if you've got specific projects, give us a shout. It's easier to discuss specifics one-to-one.
Okay, great. And Pam, a couple of questions from Stuart Wilson here. I'm trying to get the grasp of, I think he's replying to some. A very recent one that's just come on is regarding Raptite degrading in UV light over time, and how quickly do you have to overclad? So that's one we can answer. And also, if you could just look on the feed, there might be one there surrounding kind of humidity and diffusion. So if you want to answer that one first, then have a look at the others.
Yeah, there's a few coming in there. I've made a few notes here as well, so apologies if jump back and forward a bit. Okay, in terms of UV degradation, like any membranes, they're plastic. They are at risk if you leave them for a long time. We do add in additives to try and ensure that and to keep that protection for as long as possible. We have also undertaken a lot of real life exposure testing, as well as the aging required by the standard. So we know that it can be left longer. And we know that that's important for certainly high rise and large scale properties which aren't necessarily going to be covered in. And especially at this time, at this time of lockdown, where sites are maybe taking longer to get to. Please be assured that, even after a year, the Raptite is still performing as that air barrier. It's not been compromised, the permeability is not being compromised, and it'll still function. But like anything, we would usually recommend getting covered in within about 4 months.
Yeah.
On the humidity side, there's a few things there about getting it leaking into it. I mean, we talk about losing heat through air, but it's a really, really good point where we want to try and limit the vapor that can pass into the wall. So making sure that your insulation is well fitted within your studs, you don't have large holes in the internal linings. It's all about this well sealed surface, ceiling and roofs and walls. Because if you get moisture in there, you can get this bypass where it can sort of sit and move about in the insulation. If air moves about in there as well, you can get washing and reduction in thermal efficiency. So it's all about making sure things fit well. That's where factory applied stuff's quite good. It's all about ensuring gaps are sealed, and it's again down to level of detail. You can build a decent house without taking too much care, but for Passivehouse and low energy, the devil is in the detail, is a simple answer with it.
Yeah. And just coming back to a question that's quite similar to the UV one, Neil had asked again a little bit earlier on, what about long-term studies on the use of high air tightness methods, air tightness tape on timber frame construction? So what happens if that degrades over time? Now, obviously there's a lot of airtight tapes that are used in a different application than Raptite, for example. We can't really comment on the internal systems.
No, exactly. I mean, I had a wee quick search out there. There are a few papers out there. There's a paper out there from 2017 where they've looked at that in Europe. Obviously, Europe has been, further on than ourselves in air tightness applications. So it's about quality. Don't substitute a cheap tape for one that's been assessed with a system, because they will have looked at that and looked at the suppliers and made sure it's good quality adhesive. So we can't really, as you see here, we can't really comment on what other people's tapes are. Certainly with the Raptite, we've now been selling this for well over 10 years. It's probably 10 to 15 years. And we still have live tape tests going on at manufacturing locations looking at that durability, and we're still not seeing any issue. It's still well bonded, well sealed. So certainly the Raptite, there doesn't appear to be any, and we don't know if there's any long-term issues. We look at that, we test it as much as possible.
And to be fair, those live tests are exposed. They're exposed to UV. They're live. They're in situ. Exterior tests. And obviously, we do accelerated aging, etc. So, but we also like to make sure with our products that we test them in a live scenario. But we can't fast forward time, unfortunately. So we can just have the confidence with the accelerated aging that it does adhere and it does stick. And so far, as Pam says, 15 years on, we're very, very impressed with the material. John, with your installation background, a couple of questions about installation. Again, on the live the live feed here. You may or may not be able to answer some of them. I'm trying to understand one from Mel around achieving lack of penetration of the insulation layer with the Kingspan system. Now, I'm not sure if that means the structural insulated panels or the Kingspan boards. So maybe Mel can clarify. Anything to comment there? And again, Mel, you can send more information to our email and we can get someone to have a chat with you. But John, do you have anything to comment on that one?
Yeah, well, the Kingspan have got, they utilise our Raptite tape as part of their cavity fill system where they'll tape the joints. So that's really, that just helps the air tightness of the joints of the boards, because we've seen some in the past where people will put PIR or phenolic boards together in timber frame and then use just a standard foil tape on the cold side. And what you can have forming there is, if you've got a slight gap in these boards, you get condensation forming with a vapor drive on the back of the foil tape. And a lot of these tapes end up falling off and lying in the cavity. So one of the benefits of utilizing the Raptite tape is because it's moisture vapor permeable and its air tightness, it will remain in place, but allow the vapor to pass through it and remain airtight. So it's a really good product for bonding or for sealing the joints on PIR or phenolic type boards.
Okay, great. And another one for refurbishment programs, do Proctor Group work with insulation system manufacturers to provide systems for IWI room in the roof? So it's fair to say, John, we have a lot of relationships with different insulation manufacturers, great relationships, but I don't think we have any products that go into these accredited systems. Would that be right?
Not in roofing. Certainly, Kingspan have it for their phenolic product in the cavity. That's part of the BBA system with the Raptite on that. So again,
for refurbishment,
refurbishment, not really. No, not that I'm aware of. It's certainly something we should probably look at, especially with the focus from the government now on large refurbishment projects.
Absolutely.
There has actually been a few we've started to look at into recently, just because with the new Green Deal, they offer sort of one warranties with the systems. So manufacturers with one product don't tend to offer warranties with systems because we're not in control of all the products in there. So there are companies that will offer the whole systems. So we are currently looking into that at the moment with them. A few of them. So
good. Okay, Natasha, a nice installation question for you here from Joe. You make the installation of Raptite look very simplistic. Surely you need specialist contractors to install a product like Raptite, and is it really as simple as it seems? Question mark, question mark, question mark.
Yes, so we sort of put a lot of effort into making sure the systems that we provide aren't complicated and therefore don't require specialist installation teams, potentially passing on a high labour cost. So during sort of product development, we do actually install the products ourselves. So most of the team have done smaller scale projects. And I know Pam's done sort of larger scale projects, as she mentioned earlier. So with anything, and as the guys mentioned before, care and preparation is key. You need sort of just general sort of building common sense, but nothing sort of too drastic or too intense. And just to make sure that the surface is prepared in, you've got all the installation guidelines. So we provide all that and we do detailing for you. So it's very much, with most of the projects, a partnership in installing, making sure they go as well as they possibly can. So Pam has told me if she can do it, anybody can. So maybe I'll have a go at the next one.
Good. And a more salesy question from Jill. How can she purchase our products and can she buy them online?
Yeah, so across the whole of the UK, we offer a sort of a variety of procurement avenues, and this certainly does include an online facility. But what we would always say is to, if possible, give us a call into the office or speak to your local representative, because sometimes we just need to sort of just talk you through installation or just check compatibility. The other thing is we do a whole host of products that contribute to the heat and moisture management of a building. So sometimes there could be a sort of another product that will assist you in achieving the result you're looking for. Alongside this, we also offer calculations. So we do a lot of technical assistance. So we've got the sort of condensation risk analysis. We can carry out a U-value calculation. And then for those more complicated sort of complex projects, we've got the analysis. So before you sort of look at sort of purchasing, I would recommend just to call it into the office, and then we can advise you of the most efficient way to obtain the products.
Okay, thanks, Natasha. Again, I'm just loving the interaction on the YouTube feed and people answering each other's questions, which is fantastic. And some great comments, like from Colin about MVHR ventilation, especially during COVID, in terms of the airflow being effective. What a good point. These are great. So we'll certainly be looking through all these afterwards. Hadn't even thought of that as a huge benefit to MVHR, despite all the other benefits. So yeah, some great stuff coming out here. Adam, I'll come back to you for a couple more, please, and then I'll try and go through the rest of them here. Paul has said, this is a good point actually, Paul's seen a number of airtight systems out there which come with a number of components. Why does your Raptite not?
Okay, well, I'll start off with saying if you look around the rooms you're in at the moment, and we can start to see the potential penetrations of that internal air tightness line. So we've got plug sockets, light switches, radiator pipes, fitted blinds. All of these are potential penetrations to that internal air tightness line. And if you're looking at sort of detailing around them, they can require those expensive or specialist components, such as airtight junction boxes, special light switches, downlighter hoods, etc. So a lot of those products to detail around those internal air tightness line penetrations. Obviously with the Raptite, we're moving that membrane external to get away from those penetrations. So a lot less to detail. We know about those penetrations from the sort of start of the project. They tend to be penetrations that don't change throughout the project as well. So when people move into their properties, they're likely to move light switches or plug sockets, etc. Whereas we know those penetrations externally are more or less likely going to stay the same until the construction completely changes. So detailing becomes a lot easier, a lot less to deal with. And the other factor is obviously Raptite is self-adhesive. So that offers a much more simpler install process, so less components required there as well to stick onto the substrate. So there's a couple of things there.
So simple answer is really if you don't need them and you can simplify it to the extent that you just need the one product, then we can essentially achieve with Raptite much easier, can't we? As Adam just said, all the penetrations, we can achieve the air tightness strategy with a much simpler approach and certainly in terms of labour for installation as well, much simpler than the internal route, which has been quite traditional.
Yeah, we do both the internal and external air tightness line. We do vapor control layers, a big part of our business as well. So we're not saying they don't work, they both work. It's just with Raptite, you are going to achieve it a lot simpler and easier because of those penetrations that you have to deal with internally.
And it's also important to say, sorry Pam, that with Raptite, we're not saying you don't need a vapor control layer internally. That's a really important point. We can analyse the condensation risk across your wall build-up. We can look at that, and perhaps our vapor barrier won't be required internally if you're using externally airtight Raptite externally as your airtight layer. And vapor barrier. However, we would need to carefully look at that, wouldn't we, Pam?
Yeah, absolutely. I mean, I was going to say that. I mean, I know that I think as Moises mentioned it as well. They thought that the vapor control, the air tightness line was internally. Traditionally, it was, but you've got to, as Adam said, think about how to detail it. How do you get round wall junctions, studs, joists, etc. I sort of did the analogy at Christmas time where it's a lot easier to wrap one box with lots of things in it than to try and wrap each and every single one of those inside items properly and neatly. So it's not saying that a vapor controller is not needed, because you do have to control that. But it's looking at how you can minimise the impact of maybe not being able to detail as well round a joist compared to, you know, putting your air tightness line outside. So it's all about balancing, very much about balance.
Okay.
One of the other key points there is that a lot of the products that are on the market, the beauty with Raptite is trying to keep it as simple as possible on site. There are air tightness systems out there that go internally where you've got different coloured tapes for high humidity areas, kitchens, bathrooms. If you run out of one, someone's just going to put the other tape that they've got some excess on. So trying to keep it as simple as possible on site is also a key point.
Yeah. Good. A question from John Greaves, which probably I'm best to try and answer. Do you have any advice with regards to the extra overcosts of achieving low energy design versus a basic building reg only house? So we did do a webinar on self-build, which you can find on our website, where I talked a little bit about my own home. So this house where I'm sitting at the moment is something my husband and I built a couple of years ago. So this is a very low energy house to the extent that it's almost at passive house levels. So it has MVHR. We didn't put it through Passivehouse certification because I don't think we realised how good energy performance we would actually achieve when we were building it. But in terms of the cost difference, again, if you want to email webinar@proctorgroup.com, I can pick this up with you personally. Yes, there are additional costs to building a low energy house, but with the right research and with good practice, they're, in my opinion, relatively minimum. So being quite familiar with the type of building materials you can buy in the industry. Some are grossly overpriced when it comes to claiming to achieve, you know, low energy performance and what they do. But with good planning and good practice and utilising quality materials, you can essentially achieve a good design without a huge amount of additional cost. So yes, things like MVHR are more expensive to install. However, they can be offset with you know, the other benefits by making the house more energy efficient, more airtight, better thermally performing. So John, I don't have a figure. Yes, I would say there are costs, but it's not huge. But if you want to pop an email to webinar, I'll pick up personally, and hopefully I can give you a little bit more of a understanding with regards to that, just based on my own experience rather than you know, what everyone does, if you like. Okay, so let me just have a look here. A few more questions coming in. John, if I can come back to you, please. Susan has asked about how energy efficient is modular offsite building, and there's a few questions here about modular in the chat, which have actually been answered, but obviously it's a bit of a common theme, people are interested in it. So if you could have a go at answering that one, please.
Yeah, I mean, the key thing with modular is really that your factory manufacturing allows far greater control of the construction and installation, as well as being able to design out thermal bridges, etc., as well as optimizing them. I had a thing at a conference a few years ago where a chap said to me, he said, would you spend £50,000 on an Audi and watch it being built in a field, or would you rather see it built in a nice factory where, you know, there's all the performance and the accredited machinery to actually do that? And houses are very similar to that. So the added quality means that the building can be completed, but it's more likely to perform as designed. So if you've got people in a factory that's installing the insulation, they've been actually trained to do that. They're not doing that on site if it starts lashing rain and then they run into the site hut because they don't want to get wet and the material's left lying or packed back into the cavity at a later date. So it's all about making sure that the offsite modular process allows, you know, for a greater degree of quality controls. It's less variables and doesn't stifle innovation and individualism design that you may think. Again, on modular offsite, that there's with them being manufactured in the factory, the design freeze is important, so that when the design's done and the drawings are completed, you don't want to be changing these because these systems are set up that the panels are made to specific sizes, and it's not so easy to adapt and modify on site. So you really have to get that right at the beginning on site.
Okay, fantastic. And John, in your opinion, is there sort of a certain build construction method which is easier to be made passive or low energy, Graham SAS? So block cavity, timber, SIPs. I think Pam touched on this slightly earlier.
Yeah, again, it depends on how, there's a lot of factors really around that, depending on how quickly you want the building built. If you want something built really quick, then you are looking at an off-site manufactured system, you know, be it a timber frame or be it what we call a hybrid frame, where they actually put the insulation and the plasterboard on the walls in the factory, and these are shipped to the site and then pre-assembled on the actual site. Some are pre-assembled in the factory, and then you have the SIP type panels where the insulation is actually manufactured and blown into the cores, so that you just join these panels together on site. So it depends on a lot of things. One, your budget. Two, how quickly you want the actual project built, and probably more importantly at the moment, you know, with the shortage of some materials, you know, that's something else to take into consideration, depending on your budget.
Okay, fantastic. Right, there's one more in the YouTube feed here, and I think we've got sort of 4 more questions via email, which I'll ask various members. So if you have any other questions, feel free to post them now. Pam, just quickly, sorry, Stuart's made another good point slash question. Would you say the position of the VCL depends on the type and the thickness of insulation? Great point. So how does that impact?
Absolutely. That's very much a factor we have to take into account. There have been, certainly with SFS type constructions, where you may put the vapor control layer on the outside of the sheathing. You have to be exceptionally careful that what you're not doing is putting a vapor control on the wrong side. So type of vapor control layer, positioning of the vapor control layer, absolutely critical. Choice of that vapor control layer, making sure it's maybe not too vapor tight for what you want, or is vapor tight enough. You know, if you've got a swimming pool, there's no point in putting a 1600 gauge polythene in it, because it's just not going to function long term. We do have ones, very clever ones, like our ProCheck Adapt. And I think from seeing some of the emails that came in earlier on, it kind of fits in quite well with the one, Keira, if you don't mind me sort of bringing it into it, the combination of membranes and insulation and vapor control layers. So we touched on the Adapt, and we have touched in the webinar, we have done it in previous ones. So this is an adaptive one, what's called an intelligent membrane. Okay. So that allows the actual physicality of the membrane. There's a clever chemical polymer in it, which reacts similar in the way to our skin pores do. So when it's hot and the temperature's high, humidity is low, those pores open up. That product, that polymer allows vapor to pass back out, so you get that two-way drying. And when it's like us sweating and getting rid of heat, when it's cold in the winter, that polymer shrinks and closes up and becomes a much more effective vapor control layer. So it prevents the moisture from inside getting into the walls. Now, that's a brilliant product, a really clever product, but you have to be careful with what membrane or what type of insulation you use with it. So you're looking at hygroscopic, you're looking at products with low resistance. So, or, you know, so permeable ones like mineral wool, wood fiber, sheep's wool, these sort of natural building materials. So they can act as a moisture buffer. That whole wall breeze buffers, controls the moisture. Hygroscopic, you do need to make sure that it works from that roofy hygroscopic analysis side of things. If you are looking at thinner walls, i.e. using more commonly used things like phenolics, polyurethanes, polyisos, those products are high resistance. They won't hold water, they won't hold moisture. There's no point in using something like an Adapt product with it. You'd be better off using a plain polythene or one of our reflective therm to get the enhanced benefits. So it's very much about looking very carefully at the type of insulation, what you want that wall to do, what you want the function to be, and making sure that you design it. And that's where we have the experience of looking at all these different types of things together and helping you put the best combination together and assessing it to make sure that you have the healthiest building for as long as you possibly can.
Okay, fantastic. Thank you very much, Pam. Just a couple more via email. Sinclair had asked, do we anticipate the use of modern methods of construction increasing as we look to achieve net zero carbon buildings? So Sinclair, just to say that the modular MMC is actually something we're covering in more depth in our webinar on the 29th of January. So we will respond to you with our thoughts on that via email anyway, but it would be worth plugging in for the webinar on the 29th, which covers quite a little bit on that. So hopefully you can join us there. I'm just trying to look through any others that have come through here via email. Bear with me 1 second. John, so we've got 3 left, I think. John, if I can ask you, why is Raptite so good at helping to achieve low levels of air tightness? Now, we've already covered this quite a lot in this discussion. So if you want to summarise it, because it is a question that came through laterally, so obviously he's still keen to hear more of the benefits.
Yeah, that's a good question. It's partly due to the composition of the base material. Here, Raptite itself, as everyone's mentioned, and Keira's mentioned, Pam's also touched on, with the internal layer of a spun-bond polypropylene sandwich is a film, which it makes it air impermeable but vapor permeable. So the key thing with this product is really the adhesive. It's a unique permeable adhesive, which means it's easy to apply to various substrates, timber, concrete, steel. And it seals itself to these, as Pam mentioned earlier, when you're fixing through it, because of the nature of the product, that will actually draw some of the product in, so it helps self-seal on some of the substrates if you're putting fixings or nails through it. It basically, for sealing the likes of joints between panels, you can really effectively do that with this application. And with installing it externally, it's a far easier install. You've less penetrations on the internal plaster, well, not so much plaster, plumbers, sparkies, cutting holes in membranes, and then pulling cables through, small 5mm cable pulled through a 200mm gash that's been done with a Stanley knife and not being sealed up. So it allows you to in effect carry on with the trades in the internal, a lot quicker if you've got your external product on this. With a mechanically fastened membrane, the membrane can billow, so you can get air behind that, which gives a bit of a sagging away from whatever substrate you're on if it's sheathing, and that can allow air movement behind the membrane and negate some of the achievable air tightness levels. So having the Raptite fully bonded is by far the best solution. It prevents this lateral bypass and then the issues that are associated with that.
Okay, brilliant. Thank you, John. Another question which has been answered, which again, I think we'll do in more depth via email, regarding comparing U-value backstops from SBS with Passivehouse and the best for non-combustible insulation for Passivehouse. So on the non-combustible side, does any of the panel have anything to add on that?
Yeah, I mean, with regards to non-combustible, obviously that's probably relating more to your insulation. So there's quite a lot of shifts, especially on higher rise buildings, which I know is not always Passivehouse, but I know Adam's got something in his area which is quite a large, building which is being done Passivehouse, swimming pool leisure centre. So in a lot of cases, people are looking at mitigating combustible layers. We have a number of membranes in our range, both vapor control layers and breather membranes, vapor permeable membranes, that function for that, depending on the application, the positioning, the substrate. So yeah, it's very much, give us a shout, let's talk through it. We have some brochures out there with that, but you need to take it into account, but the legislation is there more for buildings over 18 metres in England and over 11 metres in Scotland, and I think Wales as well now. So it will depend on your building, but you do have to take care. You do have to think about it. And quite often it's that arson, it's during the construction, it's people being willful, or that slight mistake with the plumber's torch or something like that, so self-adhesive, again, there, you don't have that risk of it sort of, flying up the membrane. So there's different things to consider.
Absolutely. And Adam, do you have anything to add on that? I mean, you've had a lot of dealings with this particular project, which is a fantastic one, to be fair. Anything you want to add? And actually, if you can answer another one for me, Adam, after you have any comments. Moises has just asked, last question, is Raptite combustible? So would you be able to comment on that project and just answer the question as well, please?
Okay, yes. So Raptite, we'll start with the combustible one. It comes as a BS1D0 onto a sort of A1, A2 substrate, such as maybe cement particle boards, for example. So if depending on your substrates, come to us and we can talk about sort of the fire ratings as well, run over that. But in terms of breather membranes under the amendments to Part B, it's required to hit a minimum class of BS3D0. So Raptite BS1D0 is outperforming in that for high-rise applications. So non-combustible is normally seen as A1, then you've got sort of A2, and then below that would be BS1D0. So we're well within in the range for that on Raptite. So that's why it's being used and looked at a lot of projects. Also, the way it's installed. So a lot of mechanically fixed membranes will, I think Pam might have touched on it, but have an air gap behind it. So it's like a secondary ignition. Raptite is, again, self-adhered onto the substrate. So comparing that to a BS1D0 membrane that is mechanically fixed, you've reduced that secondary ignition behind it. So yeah, a lot going on with that project that Pam mentioned as well. It is classed as a high rise. It doesn't look it, but it's all sort of layered up. So from one area, there is an 18-meter high area. But yeah, using the Raptite system on it and using our fire shield as well to go over. So you've got a sort of Raptite onto the sheathing board. You've then got an insulation in between, which is again non-combustible. Big thickness, I will add as well of that. I think it's about 250 mil. Then you'll have a fire shield over the top, which can protect it from weathering, another breather membrane there, but also the additional fire benefits that the Raptite fire shield can add. If you go onto our website, you can view the video of it catching fire as well. So yeah, was there another question there that I missed?
No, I think that was it. Sorry, I didn't ask it in the most direct way, but no, you've answered that. Thank you, Adam. On our website as well, or on our YouTube channel as well, we have done a webinar all about fire and our products and also fire regulations, which is very informative. So we see it as a really crucially important topic in the whole industry at the moment. So we're very involved in it. We're well educated in it. So please have a look at that one. And if you need any assistance, our technical team is very busy with inquiries regarding fire regulations and requirements at the moment. So we'd be really happy to offer any advice if you want to touch base. Right, last question. I noticed people are leaving and saying thank you very much. That's absolutely great. We know that people dip in and out, and we're not offended if people leave early by any means, but we're happy to stay and answer as many questions as come in until the end. So the last question we had was via email from, bear with me 1 second. In fact, we have one more but Matt had actually asked, so Pam, if I can come to you here. My question relates to the issue of actual passive certification for the build and on-site quality. Only having very indirect discussions, it appears that the on-site inspections needed can be quite onerous and only undertaken by suitably qualified personnel. Have we experienced issues with this, and can it be cost prohibitive for developers and more specifically housing associations who may be looking to go down the Passivehouse route?
Yeah, I mean, we're not Passivehouse certifiers, we're not Passivehouse designers, but I have in the past been to some Passivehouse seminars and conferences where they have talked about things like this. And you're right, it's one of the actual real benefits of Passivehouse is the extent and the care and the assessment that they go into to make sure that everything is installed right. And making sure that the fabric as built is the same as designed. So yes, it is quite an onerous process. So you have to be really bought into it and you need to be engaged with these people right from the very start and all the way through. It can, some people find, be a little bit stifling because certainly with availability of products. Sometimes they don't allow a switch out terribly easily because they have to rerun it and reassess it. So for some developers and some housing associations, they may have a preference to go down this route of zero carbon or low energy designs. So it's still looking at the key areas of good insulation, well installed, air tightness, MVHR, or a design passive ventilation system, looking at orientation, overheating, taking all the elements of that, but not necessarily going down the route of actually getting the certification. So it depends on how much you want to engage with the designers and certifiers, how much more flexibility do you want in substitutions during the construction phase, which is not always a good thing. And that will help you sort of decide. So there are options, but you're looking at low energy housing as opposed to passive house.
Okay, fantastic. Good. Okay, that's all the questions. If you just, in fact, sorry, one just come through. This isn't, Stuart has put this on the YouTube feed, and he said we can answer via email, but I think it would be a really interesting one. Again, Pam, while we're just with you and on fire here, to comment on, please, or answer with regarding Raptite affecting the SDA certification or categorization of timber frames.
Yeah, it can do. We've done a lot of work on this, but mainly with our fire shield. So actually, fire shield is the only membrane that is included in the STA list of accredited or approved products for timber frame. The Raptite is brilliant, and it's really good, but you have to be aware that the performance that you get in a calcium silicate board is going to be different on a timber frame because of the contribution to the fire and the performance of the substrate. That's why it's always really important to look at what products have been tested on. So the Raptite probably wouldn't have any influence. It would be similar to standard membranes, although as we've touched on before, because it's fully bonded, you don't have that additional oxygen air layer behind it. More information on that available in the previous webinar on fire. But if you did want something that could be incorporated and actually influence those STA categorizations, then look at the fire shield. And if that's installed with the tapes overlapped, fixed back, it's less likely to billow because it's a much stiffer membrane. It can also provide your air tightness line externally. So it's not that it won't be airtight because it is an airtight product, but taped and fixed, it can do that and it can help towards that side of things.
Great, thank you, Pam. So, as I said, we've come to the end of all the questions, and I have just like to advise Jake from Avon Timber Engineering, your Raptite sample will be with you, will be sent today. So you've been chasing a sample of Raptite. Oh, I hate to read that, but we will make sure we get that out to you today, so apologies. So fantastic news that you're looking at that for use within your system. So thank you very much to all our webinar attendees. As I say, this was slightly off the cuff in terms of, this wasn't a planned webinar that we'd diaried in for January. So we did bring it forward based on, we thought people will be at home. We had really good feedback from our previous webinars with requests for some replays. So that's what we have delivered today with this new question and answer series. So we're back on the 29th of January, so Friday the 29th of January, 10 a.m, and the topic is physics and applications of construction membranes. So again, interestingly, a lot of questions and comments coming through about the differences between vapor permeable, air permeable, MMC, a ton of topics that we're actually going to be covering on that webinar, which is completely new content. So we will look forward to seeing you then. It still helps us if you can give us a thumbs up, or if you subscribe to our YouTube channel, you'll be made aware of any new content we put on our page. And as always, you will be receiving a follow-up email after this webinar. So there you'll have a link to a replay. You'll also be able to circulate that to your colleagues, friends, if you feel anyone else will be interested. There will be a link to a short survey. If you have time, please fill it out. We really do read these. I read the comments personally. We will follow up on any comments you might have, and we also note anything of interest for future webinars and anything we can improve upon. So we won't take offence, and please be as honest as you can, and if you have time to fill it out, we would appreciate it. You can also download your personalised CPD certification on the same link, www.proctorgroup.com/webinar. All our staff are working from their home offices. So we have a big technical team, we have a big sales team, and they are there to help. So you can request a Zoom meeting, you can bother them with emails, live chat. As I say, there's so many different methods to be able to contact us. So please touch base with your questions. We can review your drawings online, or you can send them through to us. So anything that you need assistance with, even if it's not related to a Proctor product, the technical team can still give impartial, advice on things like insulation, wall build-ups, etc. So we will do our best to help. So I think that's it. We'll hopefully see you on the 29th of January. Thank you very much. Sorry for a couple of the teething problems with a couple of microphones, and that's just the joy of live Zooms. I've got my cats hidden away in the utility room today, so none of them are featuring on today's webinar, but it's just part and parcel of working from home. So hopefully everyone manages to stay safe, keep navigating through the challenges of COVID, home working, the lack of social things we're allowed to do, and I wish everyone the best for 2021, and we look forward to seeing you again soon. Thanks everyone.
Thank you. Bye.
Bye.
Bye.